All right, so then we got these last three problems. This is using your graphing calculator. So I'm going to show you how to do that using your graphing calculator. It's very similar if you have a Casio. If you have questions on that, just let me know. Okay, so we have a rocket's path is described by this equation. So h equals all that, where h represents the height and t represents time. A plane is flying at the altitude of h equals 2,500. Is it possible for the rocket that it could hit the airplane? If yes, identify the possible points of intersection. So here, again, you're welcome to use your graphing calculator for this. Again, you probably wouldn't even be able to do this very well on your, because of the numbers are so big, like being able to graph that on a piece of paper, or doing it by substitution would be very difficult as well because we have decibels. But you could probably figure it out. You'd have to use the quadratic formula for it to find the solutions. But here, this is how we're going to do it on our calculator. Okay, so first off, you're going to put in the equation. So turn it on. Y equals, put in your equation. Sorry, I messed that up. So negative 4.9. Again, we use x for anything. So even though this says t, we're going to use x plus 240 x and then plus 3. So there's one of our equations. And we'll go and type in the second equation. So this one's just y equals, or h equals 2,500. So now we have the two equations. Again, if we look at this, you should be able to realize that this window, we're going to need to make our window really big. The airplane's at 2,500 feet or meters or something, and we're going to need to change the window so that it includes that. So you could graph it, but you probably won't be able to see much. But if we go and change our window and make the Y max to at least be 2,500, I'm going to maybe do 3,000, and then maybe we could have a better idea of what this is looking like. All right, so now you can see that the horizontal line is the airplane, and this is the rocket. Again, we're going to need to extend this further. So I can't even see the vertex yet, so maybe we could quadruple this. So I think right now it's x max is 10, but maybe let's try 40, or maybe you could try 50. So that looks a lot better. We can't see the other x-intercept, but we don't really need to know that. We just want to see where these two intersect. So to find the intersections on our calculator, we'll do second trace, and then we're going to choose intersect. So that's what we're trying to find, is where these two lines cross each other. All right, so move your cursor to where one of your intersections is. It gives you instructions right there, first curve, and then it will say second curve, but really we only have two curves, and it automatically switches to the second curve. So just push enter, enter, and then push enter one more time, and now it should say intersection, and this would be the, I think it's time, right? T is time, and T represents time. So we could say, it doesn't say, but we'll say seconds. So after about 15 seconds, the rocket is the same height as the airplane. Okay, so it's possible for the rocket to hit the airplane. So that's one of the two intersections. We need to come up with that one. So second trace, second trace, and then intersect. And then we'll go over to the second intersection. And again, we'll just push enter, enter, enter. And it says our second intersection is at about 34 seconds. Okay. All right. And then just for the heck of it, we're going to do number 4 as well. So go to our y equals, we'll clear both of these out, and we'll put in the new equation. So the second equation is x squared plus 5.5x plus 1.2. And then the second equation is 2.3x minus 1.7. Okay, so now our window is actually going to need to be a lot smaller now. So I'm just going to go to, like, we could push graph, but again, this is so high that you're not seeing it very well. So what I'm going to do is I'm just going to go back to zoom and do 6, which is standard. So now you can see the parabola a lot better. Okay, and it looks like these two might intersect at one point. If you're not sure, you can always just go to second trace and we can do intersect. Put your cursor where you think the intersection is and push enter, enter, enter. And what do you know? It's trying and it's trying, and it says that there's no sign change. AKA these two things are not touching each other. If we go back to the graph and we go to zoom and zoom in, we could go where you think that intersection might be and push enter. And this will zoom us in. And what do you know? Those don't even touch each other. It looks like they might be, but they're not. Okay? So if it ever gives you an error when you're trying to do this, then it's basically saying that there's no intersection. All right, so that finishes up the lesson for today. If you have any questions, let me know. If you are doing a Casio, it's the same sort of thing. You'll push, like around here, you'll push G solve, and then I think the same button will say something like intersect, and it'll be abbreviated, and you'll do the same, okay? But if you have any questions, let me know. All right, we'll see ya.